As we know that time response has two parts. One is transient response, the other one is steady state response. So all the time domain specifications that we have seen are time transient response time domain specifications. There is only one specification in steady state response, that is a steady state error. So steady state error gives the accuracy of the system, how much system is accurate. So we'll see what is the steady state error. What is error? The error in control system is the deviation of the actual response to the desired response. So we take R of S as a reference or the desired response, C of S is the actual or controlled response or controlled variable response. The ultimate aim of any control system is see that your actual response is equal to the desired response, or output variable is equal to the input variable. Maybe sometimes in the presence of disturbance, or sometimes if the input is varying, the output should also vary according to the input variations. Now the error is the difference between input and output. There are two types of errors. As I said, in time response, two parts, transient, steady state. In error also we have transient, steady state. But we know the transient response will die out after some time. So there exists some error in transient response, but that error is also going to be die out after some time. But in steady state, the steady state response remains same after the transient response. Therefore, steady state error will remain same. So in steady state, what is the deviation from input to output is the steady state error, and steady state error gives the accuracy of the system. Now let us look at the closed loop block diagram. G of S is a forward path transfer function, H of S is the feedback path transfer function or sensor transfer function. Now R of S is input and C of S is output. I want to define where is the error. Now we know that from very clear, if the summing point, after the summing point we can assume it as E, that is E of S. So E of S is the error. Let us see how to find the E of S. So from this block diagram, very clear, your E of S is equal to R of S minus H of S into C of S. We have negative feedback, therefore minus. So we can write here E of S is R of S minus H of S into C of S, or C of S into H of S. Again, I want to write C of S in terms of E of S. So E of S here, G of S and C of S. How can you write C of S? E of S into G of S. Then you substitute here, then you will get the result it as E of S is equal to R of S minus G of S H of S into E of S. Now I want to take this E of S right hand side to the left hand side, and if you take common E of S, it results E of S into 1 plus GH of S is equal to R of S. Then we can write E of S as now E of S is equal to R of S divided by 1 plus G of S. So this function is very important in steady state error concept. So this function is called the error function. So what is that error function? E of S is equal to R of S divided by 1 plus GH of S. Now how to find the steady state error? So there are different ways to find the steady state error. Generally there are three methods we can say. One is, as the error function is available, apply inverse Laplace transform so that you will get E of t. And we know the steady state error or error at infinity. Therefore E of infinity is the steady state error. Generally we represent it as ESS. Capital E is error, SS subscripts are steady state. So ESS is nothing but error at infinity. Therefore ESS we can write it as is equal to limit t tends to infinity E of t. So E of t you can find out from the E of S function. E of S function, apply Laplace transform, inverse Laplace transform, get E of t, substitute in the limit t tends to infinity E of t. So that will be the steady state error. This is a one method. Now what is the second method? So in second method, E of S is already available. Then I am going to use final value theorem. So what is the final value theorem? if you apply the final value theorem, you will get ESS, steady state error, is equal to limit s tends to 0 s into E of s, and this is the final value theorem. Directly will get the steady state error. Third way is, so we know that steady state error is E of infinity. Then for any unity feedback system, your E of infinity is R of infinity minus C of infinity. So R of infinity, you know the input, then we can write the R of infinity. For example, if it is unit step input, R of infinity is 1. Then C of infinity, you have C of s function. Then for that we can use final value theorem again. You can find out C of infinity. R of infinity minus C of infinity directly gives us the steady state error. So out of all these things, generally we go with the ESS is equal to second method. ESS is equal to limit s tends to 0 s into E of s, where E of s is R of s by 1 plus GH of s. So sometimes we can also write the error transfer function. Error transfer function is E of s by R of s is equal to 1 by 1 plus GH of s. So this is about my error function and as well as the error transfer function.